In this video, we will show you how the Appranix Cloud Resilience Copilot rebuilds a software-defined NetApp storage-based e-commerce application across to another cloud region, completely on demand. We will discuss how organizations choosing NetApp solutions running on hyperscale cloud platforms like AWS can achieve much better resilience using an application-centric holistic resilience model. Moreover, they don't have to spend cloud infrastructure at the recovery region until necessary, thereby not only avoiding the cost of unnecessary infrastructure, risks of drift of the recovery environment from the production environment, risks due to unnecessary scripting, manual efforts, and unreliable runbooks that are not run consistently. With a robust and proven cloud resilience model pioneered by Appranix, organizations not only achieve a reliable recovery from cloud outages and ransomware attacks, but also new capabilities to increase the SLA guarantee while running complex enterprise applications on hyperscaled public cloud platforms. Cloud applications are not like traditional data center-based applications. Even if they have been lifted and shifted to the hyperscaled cloud environments, they not only use infrastructure services like VPC, load balancers, cloud DNS, but end up using serverless and cloud database services, and maybe in some cases, containers as well. It is important to think about a holistic application-centric model beyond the traditional backup and DR models, so organizations can make use of all the cloud-native capabilities, like recovery as code, to avoid recovery runbooks automatically. Appranix's patented dual-vault cloud time machine with recovery as code can rebuild entire distributed cloud application environment with all the necessary cloud services, like an exact copy from the production environment, along with application data from the NetApp software-defined storage, so users can confidently rely on a robust recovery mechanism. In this video, we will show both build and the rebuild of a multi-tier enterprise application. The first part is the build of a distributed e-commerce application using Windows IIS, SQL servers, controlled by Windows AD, along with a NetApp FSx service as the underlying storage layer. We will build this application environment in the AWS US East region. NetApp FSx and application environments will be deployed in two different VPCs. NetApp FSx will be configured with the snap mirror replication across to the US West region. The second part is the rebuild of the application using Appranix Copilot in the US West region. This part will show you how fast you can rebuild the entire application environment after an outage in the US East region or after a ransomware attack. We will show you how all the AWS services, NetApp FSx, the SQL server with all the data properly configured, and the IIS servers, and the Windows AD recovered with a single click. In the end, we will also verify how the e-commerce application runs with the shopping cart from the US East region, with all the data intact. The demo eShop web e-commerce application is a typical web application hosted on Windows IIS server with SQL database, and it can scale based on the user needs and is assumed to be available 99.95% of the time. Any disruption in the back end affects a company's revenue and reputation. Let us log in as demo user and fill up the shopping cart to see if the shopping cart is recovered properly after the rebuild. Go to My Orders to make sure the order details are intact. Now, let us break down our application architecture in the backend and see how we have built it on AWS. The total build time for this entire application architecture is about 16 man-hours. Our main e-commerce application is hosted on two EC2 instances that are front-ended by an application load balancer. The back-end of our application uses MS SQL, and the SQL nodes use a NetApp FSx storage. All these instances are domain-joined in an Active Directory, which is deployed on an instance acting as the domain controller. For connectivity to other machines, a remote gateway instance is used. The DNS name of the load balancer is provided as a record set in the public hosted zone on Route 53 DNS service. We wanted a no data loss architecture, so a second FSx cluster is hosted across to the US West region, to which our primary NetApp cluster is peered. Asynchronous replication between SQL volumes is enabled through a snap mirror relationship. VPCs are peered to establish connectivity between the NetApp clusters. Here is all our instances, application load balancer and Route 53, which has record pointing to the load balancer DNS name. Select the primary region in the AWS FSx page to see how the NetApp file system has been created in the region. This NetApp FSx cluster is paired with another FSx cluster in the US West region. Let's see how application services connect to web and SQL services to service the e-commerce application. Windows Active Directory acts as a domain controller for the entire application and handles all the authentication and authorization services. As mentioned, there are two application servers so they can scale based on the user load. Looking at the application server configuration and how the e-commerce site is served using the regular HTTP 5001 port. The second application server is configured with the same configuration. All these configurations will have to be backed up properly in order to rebuild across to another region. If you look at the SQL server configuration, the second data disk is coming from the FSx volume. This volume where all the shopping cart data are stored and eventually replicated. Using the SQL Server Management Studio, you can take a look at the table where the actual shopping cart data is stored. The entire SQL data server and all the configurations, including volume mapping, should be backed up and replicated to the US West region for consistent recovery. All the application servers, including Windows Active Directory configurations, SQL database, and all the configurations should be consistently captured and replicated continuously, while the NetApp FSx replicates the critical data to the US West region asynchronously. Using the NetApp Blue XP, you can manage multiple clusters on a single console. We have set up the snap mirror replication to make sure all the data written to the primary cluster volume gets asynchronously replicated to paired FSx cluster in the US West region. All the records that end up in the e-commerce shopping cart would have been replicated to the target cluster. Now that you know how we have built the e-commerce application using various AWS services on Windows platform, we can protect the entire application environment using Appranix. To do that, first we need to discover the entire environment using a cloud connection. A cloud connection will auto-discover all the cloud services in your AWS account. You can see how both AWS East and West regions' resources are discovered. Appranix discovers the target region's existing services to avoid colliding with those services in the event of a rebuild after a disaster. Now, in order to represent the entire e-commerce application, you have to create a cloud assembly. If you pick the top-level instances or tag them in AWS, Appranix will automatically reverse blueprint all the necessary AWS services belonging to the e-commerce application. You don't have to manually add or select necessary AWS infrastructure services, as Appranix knows the connectivity between them. Even if the application servers change or new volumes are added or other changes are done for any other reasons, Appranix will automatically discover, back up and replicate them. You can now add a set of policies to protect all the Windows servers, their configurations, application server images, SQL database images, along with Windows Active Directory and all the dependencies intact. In this case, we have set up just one 15 minutes policy to capture the entire architecture every 15 minutes and replicate it across to the US West region. Let's now simulate a DR event recovery. Assume that all the services in the primary region is down due to a cloud service outage. Outage might last a minute or hours. Appranix can rebuild all the resources in the DR region, including the Windows instances, their configurations, images, application load balancer, VPC, and all the dependencies from a 15 minutes ago copy. This picture shows a multi-zone SQL cluster setup. Appranix can rebuild entire multi-zone architecture appropriately and connect all the necessary components and services. The snap mirror replication relationship will be broken off so that our secondary NetApp will become read and write accessible, and the volumes with all our application data will be mounted to the SQL nodes. The record set in the public hosted zone will be pointed to the DNS name of the recovered application load balancer. To get the e-commerce application up and running with all the application data, configurations and shopping cart intact from the primary region, Now, let us open the latest timeline from our cloud assembly. In this page, we can see all the information regarding the timeline, like the protected resources and replicated resources across the operational regions. For recovery, click the Recover button on the top right corner. Enter a name for the recovery. Select the cross region as the recovery type. Verify the recovery region, VPC type, and entire assembly to recover all the resources protected by the assembly, and click Recover. Now Appranix will rebuild all the resources in the US West region. In the AWS Console's recovery region, we can see our instances, including the application servers, Active Directory node, and the SQL server, have come up properly and running. Once the rebuild is completed successfully, we can get all the information regarding the rebuild on the recovery page, like the time the recovery started, duration, etc. You can see that Appranix just took 5 minutes and 4 seconds to rebuild the entire multi-stack architecture along with the data. Also in the Recovered Resources pane, we can get a detailed summary of all the recovered resources. Let's take a look at the cloud-native recovery code written by Appranix Copilot for rebuilding the entire e-commerce application stack with all the resources, from the VPC network up to the application servers, including the Windows AD and all the configurations. There is no need to write any runbook or to script for completing the recovery. Appranix has rebuilt everything from a 15 minutes ago copy in the California region in just over 5 minutes. Let's start the verification process. As you can see that the network resources have been recovered intact. Also, our secondary NetApp is now active with the broken snap mirror relationship from the primary. Now, US West region is the active storage backend for the e-commerce application. We can verify that the Active Directory and the application services have been properly rebuilt in the recovery region. Make sure all the domain controller information is intact. Verify that the application servers and their configurations are properly rebuilt. We can also verify the NetApp volume has mounted successfully. And use the SQL Server Management Studio on the recovered SQL Server node to check if all the shopping cart data have been recovered as well. On the Route 53 public hosted zone page, we can ensure that the DNS record has been updated and is now pointing to the new load balancer's DNS value to make sure our e-commerce application is up and running from the West Coast region, with all the shopping cart data and settings intact. Use the same username and password as the primary region to log in as if nothing happened, to continue with your purchase. Now that we have tested the recovery, we can reset the entire environment and delete all the recovered resources by going to the Cloud Connections. Choose our cloud connection and verify the discovery status. And then navigate to the Cloud Assembly page and select E-commerce Cloud Assembly. Click the Timelines pane. Choose the recovered timelines. Click on the timeline that we just recovered. In the Recovery pane, we can see the latest recovery. You can find all the recovery details here. We have to reset all these resources. In the top right corner, and click Reset Now to delete the resources. Record the delete for the audit logs. Open the AWS console in the recovery region. We can see that the recovered instances are now being terminated. We have to now enable Snap Mirror Resync, so the US East region data gets replicated to the US West region again. For resyncing the replication between the mirrored volumes using the NetApp Blue XP console, enter the secondary NetApp cluster. In the replication relationships, we can manage our replication configurations. Currently, the replication relationship is in the broken-off state. Choose the Resync to restart the relationship. Now our replication relationship will be re-established to the snap mirrored state. Once the state has changed to snap mirrored, replication between the primary cluster volumes and the secondary cluster volume continues. Now you know how the Appranix Cloud Resilience Copilot offers a transformative cloud resiliency solution for managing NetApp storage-based e-commerce applications on AWS. It provides robust protection against cloud outages and ransomware attacks while drastically reducing the costs and risks. This empowers organizations to confidently run complex enterprise applications on hyperscale public cloud platforms. Let's go beyond the traditional backup and DR model and achieve much better applications SLA.